In a network security assessment, there is a distinct moment when passive observation locks onto a target and becomes an active, intrusive connection. Standard port scanning is a process of elimination. It pings IP addresses and checks open ports to confirm that a computer actually exists on a network, and perhaps what operating system it's running. But knowing a system exists is not enough to compromise it. The next phase, enumeration, establishes a direct, unauthenticated connection to the target to probe its internal logic. By interacting directly with the machine's services, an attacker can extract a wealth of structural data. This includes local user groups, hidden administrative file shares, and the broader topology of the surrounding network. Extracting this data requires weaponizing a deep understanding of how specific operating systems are engineered to communicate. In most modern enterprise networks, that means navigating a dual landscape: Windows-based domains handling user workstations and Active Directory, running alongside Unix or Linux clusters powering web servers and databases. For decades, Windows environments relied on legacy protocols for local communication. These protocols were designed for ease of use, which means they natively leak structural data to anyone who asks for it. Enumeration shifts the assessment from observing the perimeter to extracting the target's internal architectural blueprints from within the connection. In a Windows environment, one of the primary targets for blueprint extraction is the Network Basic Input-Output System, or NetBIOS. It's a legacy programming interface that allows computers to communicate over a local area network to share files and printers using the Server Message Block Protocol. When a Windows system is assigned a name on the network, it is given a NetBIOS name. The user only controls the first 15 characters. The final 16th character is reserved for a 2-digit hexadecimal identifier assigned by the operating system. These suffixes denote specific services. 20 indicates a file server, while 1C identifies a domain controller. Filtering a network scan for that specific 1C suffix instantly isolates the domain controllers. These servers house the Active Directory database, making them the most critical nodes on a Windows network. Finding the domain controller is the first step. Querying it relies on a long-standing weakness in legacy Windows architecture, known as a null session. A null session allows a user to establish a direct connection to the hidden IPC $ administrative share. It does this without requiring authentication. The attacker simply submits completely empty strings for both the username and the password. This feature was originally left open for backward compatibility with older systems. In practice, it allows unauthenticated attackers to query the domain controller and download a complete list of users, groups, and network shares. You don't need specialized malware to execute these queries. Windows includes native command line tools that perform NetBIOS extraction, beginning with the Nbtstat command. By running Nbtstat against a target IP address, an attacker forces the remote machine to dump its NetBIOS nametable. Looking at this command prompt output, we can clearly see the registered names grouped by their unique hexadecimal suffixes and status. Once a host is identified, another native command, netview, is used to map the exposed resources across that specific machine. This netview scan returns a list of connected server names. Notice the target labeled Metasploitable. The output explicitly lists its remark as a Samba server running on Debian Linux, immediately revealing its architecture. With the exposed shares mapped, an attacker can execute the netuse command to mount those remote folders directly to their own local machine as if they were physical hard drives. When native commands are restricted, third-party utilities step in. Tools like Foundstone's dumpsec connect to the target to systematically download raw registry permissions, user tables, and local security policies. On the Linux side, security testers rely on enum for Linux to pull user and group data via Samba, while administrators often use the Hyena GUI tool to visualize those same Windows shares and logon names. Because these queries rely on standard administrative commands rather than exploit code, an attacker maps the entire Windows architecture without triggering most endpoint detection systems. Windows domains are only half the enterprise. The underlying network infrastructure, the routers, firewalls, and Unix server clusters, presents an equally massive attack surface. Here, the target is often the simple network management protocol, which natively operates when a request strikes UDP port 161. SNMP was engineered to let network administrators monitor system statistics, device health, and hardware configurations remotely from a central console. To authenticate these requests, SNMP uses community strings acting as passwords. However, many devices are deployed with their default community strings intact, typically set to the word public. This configuration turns a diagnostic protocol into an open data leak. Security testers query these devices using the SNMP walk utility. Sending a request to UDP port 161 with that default public string asks the device to report every piece of data it monitors. This query output shows the exact return of an SNMP walk command. Alongside the numerical object identifiers, or OIDs, the system explicitly broadcasts its operating system version, identifying itself as a VIATA/VIOS router. Pinpointing the precise processor architecture and software version is a strict prerequisite for an attacker. It ensures they select the correct payload to exploit the target without crashing the service. A misconfigured management daemon on a Unix system operates exactly like an exposed NetBIOS share on a Windows machine. It openly broadcasts the network's internal blueprints to anyone listening. The data leaks aren't limited to hardware statistics. The finger utility is a legacy Unix daemon that runs silently in the background, listening for requests on TCP port 79. Finger was originally designed to let administrators check the status of remote users on a shared system, showing who was logged in and when they were last active. Today, a single command hitting port 79 forces the server to return a complete list of valid active user identities. Harvesting a list of confirmed user accounts reduces the friction for subsequent attacks. It focuses password brute-forcing attempts on accounts known to exist and provides precise targeting for social engineering campaigns. Leaving legacy daemons active provides zero operational benefit, while turning benign system telemetry into a primary targeting vector. A modern enterprise network is a hybrid environment. It relies on both the Windows domain controllers and the Unix server infrastructure functioning together. To map this complex surface, enterprise security teams use automated vulnerability scanners like Nessus and OpenVAS. In this OpenVAS report, the scanner automatically identifies a critical weakness on a remote host. It flags an open SSH port and successfully logs in using the default MSF admin credentials. These graphical platforms are incredibly efficient, but they do not use magic. Under the hood, they are simply executing automated scripts of the exact NetBIOS queries and SNMP commands we've just covered. Here, Nessus runs a script to probe server message block protocols. The output directly enumerates the hidden administrative shares, the admin $, C$, and IPC $ pathways exposed across the Windows target. The value of an enterprise suite is its ability to rapidly parse these disparate protocol leaks from across a massive hybrid network, compiling them into a prioritized list of actionable exploit targets. Vulnerability scanners do not invent new ways into a system. They merely scale the process of extracting the foundational architectural flaws of the target operating systems. Enumeration bypasses software bugs to exploit the way systems were specifically engineered to communicate. Looking at a Nessus profile reveals dense information-level disclosures. The scanner easily pulls details of SMB and DCE services. Moving right, the sidebar explicitly identifies the OS as Microsoft Windows 7 Professional, handing over this intelligence without triggering any defensive countermeasures. Defending an environment requires the explicit termination of the legacy broadcast protocols and management daemons that continuously announce a system's internal structure. You cannot defend an enterprise network if you do not understand exactly what its architecture is broadcasting to the world by default.